Okay, Sandy, let's take a look at this one. If we're going to add these radical expressions, what we have to do first is figure out whether they're like. And, if we're going to decide whether these things are like or not, we need to first simplify all of our radicals and see what is going on there. So I'm going to start by looking at the square root of 5x cubed. Okay, and I'm going to look for pairs inside of there, and 5, the only way to make 5 with multiplication is 5 times 1, so I just can't simplify the 5. There's no pairs of factors with that piece inside there, but the x to the third power, we can simplify that, and we showed you a couple of ways to think about that one. We could think about it like x times x times x, and then we can look for pairs inside of that, and here's a pair of x's, right? And so every pair inside of that factorization is going to let us pull one of those numbers out. So because I have a pair of x's, I can pull a single x out. And then whatever's left over, whatever didn't pair, has got to stay in. So in this case, I had one x here that didn't pair, so that's got to stay in. And that's really all I could do to simplify that one. The alternate way to simplify that is just to remember that your index up here is an implied 2, and we can just divide our power by our index. 2 goes into 3 one time with 1 left over. That quotient means that I can pull one x out. This x here can be pulled out because of the quotient up here. And this x here has to stay in because of our remainder. The quotient's going to tell you how many you can pull out, and the remainder is going to tell you how many have to stay in. So regardless of which way you choose it, you're going to end up pulling one x out and leaving one x in. And that first term simplified down is going to give us 8x times the square root of 5x. Let's look at our second term now. So we've got 4x times the square root of 45x. Again, I'm just going to treat each of the factors inside my radical as just a little separate calculation here. I'm going to break that 45 down. Okay, and I'm going to use a prime factorization. So 45 is like 3 times 15. 15 is 3 times 5. And 5 is 5 times 1, right? And, as usual here, because we're dealing with a square root, we're looking for pairs of numbers in our prime factorization. So got a pair of 3's. So bring my 4x down. I don't want to lose that. The pair of 3's inside that prime factorization is going to let me pull 1 3 out, right? And then whatever didn't pair, in this case the 5 did not pair, has got to stay in. And then the x that I've got in there, not enough x's to do anything. I need at least 2 x's inside of a square root to do any simplifying. So I'm just going to bring that down as well. Now cleaning this up, multiplying the 4 times 3 on the outside. This term is going to simplify like so. Okay, so 12x squared of 5x is my simplified form there. Okay, and so now let's look at what we have when we put those things together. Alright, so now that we have each of our radicals simplified, we can see that the variable parts and the radical parts are identical in these two terms. It makes them like, right? You got the same x's, you got the same square root of 5x's in both of those terms. And when we have like terms or like radicals, we can combine them by just adding the coefficients. So 8 and 12 is going to give me 20, and then leaving the variable and the radical parts unchanged. So 20x times the square root of 5x is going to be my, my final answer here. Okay, so in general, when we're adding these radical terms, our first step is to simplify as much as we can with all of our radicals, because that's the only way we're going to know for sure whether our terms are like or not. And once we figure out if our terms are like, we can apply our rule for combining like terms to clean them up. And so this time we wind up with 20x times the square root of 5x. Okay, so hopefully this is helpful. Let me know if you have any other questions.